Alright, so this is Chapter 4 test review, so let's look at this. Telephone company charges $28.75 per month, plus 10 cents for a minute for long distance calls. So now, the wording of this one's kind of strange. So if you wanted to figure out your monthly bill, well, your monthly bill is always going to start out with $28.75 plus your long distance calls. So X equals Y, just like that. So that's, let me put a 0 there, 0.10x. Alright, write the slope-intercept form for a line that passes through the coordinate 7, -3, and has a y-intercept of 2. Alright, now this one's just kind of strange, but if we think about it, y equals mx plus b. It doesn't tell us the slope, but I could figure it out because that's b, that's x, and that's -3. So if we plugged all that in, -3 is equal to 7m plus 2. Move the 7 or move the 2 over. So I have 7m equals -5. Excuse me, that's an equal sign. Divide by 7, m equals -5 over 7. So my equation then is -5 over 7x plus 2. Looking at the equation here on number 3, well, let's just kind of count here. Well, it looks like right there would be my x or my y-intercept. So I'm going to go ahead and say that my y-intercept is y equals, and we'll go to the end. It should be a -3, and then we'll count. It looks like I also crossed right there, so it looks like I have to go up 2 and over 3. So up 2 and over 3, rise over run is 2/3 x. Okay, let's keep moving on down here. Number 4 looks like, okay, got 2 coordinates. Need the equation for the line. Well, we'll go slope formula. Subtract my y coordinates, 4 minus -2, all over 3 minus -1. Plus, 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 so that is 6 over 4, 3 over 2 then. Alright, so my slope is 3 over 2, and let's just use point slope form this time. 1 minus, and I'll use the second coordinate, 4 equals 3 halves, and then it's x minus 3, that's an x. Distribute the 3 halves, we should get, let's see, y minus 4 equals 3 halves x minus 9 halves, that's 9. Add 4 over to here, so that's a 4, y is equal to 3 halves x, and let's see, 4 is bigger than 3 halves, or excuse me, than 9 halves, excuse me. If I wanted to change that to a common denominator, it would be a 2, which would make that an 8, right? Oh, it is bigger. So that's still going to be a minus 1/2. Okay, let's look at number 5. Undefined slope. Okay, if I have undefined slope, well, let's think about it. If I'm undefined, that means I'm going up some number, and I'm not going left or right. So I have to be undefined. So I'm some number up or down, I guess, over 0. Well, I can't divide by 0, so that means I'm a vertical line. Okay, now vertical lines, you just have to worry about the x value. So x is equal to -6. There's my answer. Not too bad on that one. Write an equation in slope-intercept form. Slope is 1/3, and that passes through the point -2, 8. I can do that, and we'll use slope-intercept form. So y equals mx plus b, and well, that's 8 equals 1/3 times -2 plus b. 1/3 times -2 is -2/3, so I have 8 equals -2/3 plus b. Add that over, so we should get b is equal to, let's see, common denominator would be a 3. So if I times 8 by 3, I get 24. Add 2 to that, or if I, excuse me, let me show my work. 2/3 plus 2/3. So if I add 2/3 to 24 over 3, I should get 26/3. So my answer is y is equal to 1/3 x plus 26 over 3. All right, and let's go here to the last question. Write in slope-intercept form. Well, it's already been set up, so all I got to do is distribute. So I end up with y plus 4 is equal to negative 12/7 x plus 12/7. Subtract 4, and I can change this 4 to be common denominator would be a 7, so I times everything by 7, so I should get negative 28 over 7. And if I take 28 away from 12, I should get an answer of negative 12 over 7 x minus 16 over 7. Okay, so you can't really read that. Let me rewrite that. Y is equal to negative 12/7 x minus 16 over 7. There we go. Let's go to the next page. Okay, second page. Looking at number 8, same thing as number 7. Let's just distribute that 3. So y minus 2 is equal to 3x minus 12. And then let's add the 2 over. So y is equal to 3x minus 10. Okay, number 9. Oh, slope-intercept form of a line parallel to the graph of this one. Well, to get a parallel line, I need equal slope. I don't even know the slope of that line, so we better solve for y. So if I subtract 2x to the other side, y is equal to negative 2x plus 5. Well, there's my slope then. I know that my slope of my line has to have that. And I need that coordinate 0, 1, which is nice. And I'll use point slope form this time. So it's y minus 1 is equal to negative 2 times x minus 0. Distributing that, I just get negative 2x. And if I add 1, y is equal to negative 2x. And then if I add the 1 over, I should get plus 1. Oh, number 10. Hey, perpendicular line this time. And I was nice to you and I made sure we got the slope. Well, that's the slope, but I need a perpendicular one. So that would mean I would need the opposite reciprocal. So let's change the slope to 2/3. Hey, and I got a point there, so let's use that. So, and I'll use mx plus b. I'll use just the normal slope-intercept form. Excuse me, let's erase that a little bit. Y is negative 2, so let's put a negative 2 there, and then I have 2/3 for the slope times 3 plus b. Now if I multiply that, 2 times 3 is 6, divided by 3 is 2. So now I have negative 2 equals 2 plus b. Subtract 2, I get b is equal to negative 4. So my equation then is y equals 2/3 x minus 4. And let's keep going. All right, scatter plot showing the data percentage of total internet users who visited an online store on a given day in December. Includes the point 2008, 2, and 2010, 4.5. Write the slope-intercept form of an equation for the line of fit. All right, so if we do this, let's see here. Let's go. Well, we're going to go 4.5. Excuse me, I forgot to select the marker. 4.5 minus 2. And basically it's going to come down to 10 minus 8. I just don't want to write it all out. So the top is a 1.5 divided by 2. 1.5 divided by 2 should be 0.75. Okay, I know. Me doing decimals, it's crazy. Now, let's pick a coordinate. Well, let's just take this one because it doesn't have a decimal, or I don't have to use the decimal 2.0. And I'm going to use slope-intercept form. So I'm going to say that y is 2 equals 0.75. Ooh, excuse me. Let's not do that. Let's do that. Now, like that one example I showed, we're talking about, clearly, guys, this is a year, okay? 2008 is a year. Let's just put a benchmark out there of the year 2000 is the first year. Okay, so that would be year 0. So instead of putting 2008 in there, let's just put the number 8. Okay, because and let that means 2008, just so I don't get this really, really, really big negative number. Okay, and so then we'll go plus B. Okay, 0.75 times 8 should be 6. So now 2 is equal to 6 plus B. Subtract 6 over B is equal to negative 4. All right, so Y is equal to 0.75 X minus 4. Okay, there we go. All right, now these ones are going to get a little tough for me to do on this. I got to make a scatter plot. Okay, so if I'm at 10 minutes, I'm at a 53%, so that's right around in there. Ooh, better select the marker. This is going to get kind of tough for me to draw, so we'll write in there somewhere. If I'm at 20 minutes, that's a 67. That's in there somewhere. I know it's close to 70, but I'm trying to do the best I can with this little tiny marker. If I'm at 30 minutes, I'm right there-ish. If I'm at 40 minutes, I'm at an 87. And if I'm at 50 minutes, I'm at a 95. Okay, so that's what I get. Now, guys, yours is going to be a little different. And now I'm going to draw a line of fit. Oops, sure. Let me erase all of those. Oop, let's just do this. Let's just stick with that. And let me do one in red. Apologize, it's kind of tough. Okay, now let me just use a couple coordinates here. Well, it looks like I'm going to use this one because that's one of the points that I went through. And it looks like I'm also going to use this coordinate right there that's slightly below this 1053. And I'm going to call the second point down there, I'm just going to call it 1050. All right, just for the number's sake. So I'm going to make an equation here. And so if I'm going to use the first one of 5095, that would mean I would have to go 95 minus 50 all over 50 minus 10. So my numerator is a 45 all over 40, which if I divide that, I should get divisible by 9 or by 5. I should get 9/8, just like that. Okay, and then I'll use the coordinate 10 and 50, and I'll just use slope-intercept form. So 50 equals 9/8 times 10 plus b. Okay, then if I took 90 times 10 is 90, and then divide by 8. Then so the 90 divided by 8 is 11.25, so 50 equals 11.25. Is that right? Yeah, that should be right. Yeah, 11.25 plus b. And then subtract 11.25, so b then has to equal, what's that come out to? 39.75, right? Let me subtract that real quick. 38.75, my bad. 0.75. So my equation or my model is y is equal to 9/8 x plus 38.75. And then what it says here is use the equation to predict a student's score if they spent 35 minutes. Well, let's just plug in 35 in there for x. So we have 9/8 times 35. So 9/8 times 35 should give me 39.375. And then we'll just have to add this back onto here. So then plus 38.75. We should get a score of around, in our case, and this is what my number gave me is 78.125%. Okay, which if we look at the model, okay, yeah, I'm probably right in there because 35 would be right in here somewhere, pretty close. So right, you know, maybe my model looks like it could be more about 80, but that's just kind of where my numbers might be a little, you know, I didn't do a very good job drawing a straight line. Okay, is it reasonable to use the equation to estimate the score received for any length of time spent studying? This one is kind of one of those you've got to think about it, okay? From anywhere from 0 to 50 minutes, I would probably say anywhere from 0 to 50 minutes, yes. Okay, yes, it's okay to use this model. However, look at our graph. After 50 minutes, okay, and I'm talking like right here, after 50 minutes, look what happened to the score received. I'm above the 100% threshold. So I would say, yes, you can use it to estimate, but not for any length of time, okay? Because after a while, you can't do that anymore. So overall, is it reasonable? I would say no. You can't have scores over 100%. So eventually, no matter how long you're studying, the highest score you're going to get is 100%. Okay, so that's how I rationalize that one. All right, looking at 15 on the last page. Graph the inverse. Okay, looks like I got a coordinate right there. That looks like 0, 6. And I got a coordinate right there. It looks like at 6, negative 2. If I get their inverses, that would be 6, 0. And negative 2, 6. And so if I graph them, 6, 0 is right there, a little off, and negative 2, 6 should be right about in there, and whoops, missed the line, but you get the point. Okay, it looks something like that. Great. All right, number 16, I need to find f inverse of x. All right, so start by step 1, changing the f of x for y, so then it's y equals 5 minus 4x all over 15. Interchange x and y, so now x is equal to 5 minus 4x all over 15. Let's times both sides by 15. 15's cancel there. And then I have 15x equals, that's supposed to be a y, I'm sorry. 5 minus 4y. Subtract 5 over from 15x, so I get 15x minus 5 is equal to negative 4y. Divide everything by negative 4. Right? And so then I should end up with is y is equal to 15x minus 5, all divided by negative 4. And just change the y back into f inverse. F inverse of x is equal to 15x minus 5 all over negative 4. Okay, let's look at number 17 now. Now this one, guys, don't panic. There's no f of x, it's not solved, but so you skip step 1, you don't have to write f of x as y, you just interchange x and y. So now it's 6y plus 8x equals 13. And it's actually like you get to skip a step. Now solve for y. Subtract 8x over, 6y is equal to negative 8x plus 13. Dividing by 6, I have y is equal to negative 8x plus 13. Over 6, sorry. And you can leave it like that if you want to. You can separate them out. But then again, change y for that. So then f inverse of x is equal to negative 8x. Sorry, I ran myself out of room. All over 6. Okay, and let's look at the bonus question for fun. In a lake, a 1-year-old bluegill is 3 inches long, while a 4-year-old bluegill is 6.6 inches long. Assuming the growth rate can be approximated by a linear equation, write an equation in slope-intercept form for the length L of a bluegill in inches after t years. Then use the equation to determine the age of a 9-inch bluegill. All right, so let's just let's assume that 1 year, 1 year means 3 inches, so let's make that as a coordinate, and let's go 4 years is 6.6. Okay, What we want is, we want to know what's x when y is 9, or if, what t is. In our case, they chose to use this as the letter T and this is the letter L. All right, so we can use the slope formula here. We can go 6.6 minus 3 divided by 4 minus 1. All right, so the top number then is a 3.6 over 3. And if we chose to divide that, I'm just going to go ahead and get the decimals, 1.2. Okay, and I'll use point slope form, and I'll use the top one. So we will go y minus 3 is equal to, and actually let me change that because it shouldn't be a y now. Well, I'll keep it as a y, it doesn't matter. I'm just being picky there. Y minus 3 equals, what did I say, 1.2 times x minus 1. Now again, guys, if you wanted to be really technical, x has now been changed to t and y has now been changed to L, but it really doesn't matter. Okay, let's distribute. Y minus 3 is equal to 1.2x minus 1.2. Add 3, negative 1.2. I should get y is equal to 1.2x plus 1.8. Okay, yeah, that 1.2 looks really ugly. Let's change that to a 1. All right, now we want to find out how old this bluegill is. So that means I have to change that for a 9. So now 9 is equal to 1.2x plus 1.8. Subtract the 1.8 over 9 minus 1.8. Oops. 9 minus 1.8 should come out to be 7.2. 7.2 is equal to 1.2x. And if we divide 7.2 by 1.2, should come out to be 6 years old, I believe. Right? I think that's right. So that's how old the bluegill would be approximately. That's what we would make a very good educated guess at.